Well, hi, this is some notes for Lesson 8, Week 3. That's our second lesson for the week. After yesterday, hopefully you get an idea for some of these exponent terms and vocabulary we're going to use. The base, the bigger number. The exponent is what we raise it to, that superscript. The whole thing is technically called a power, but if you watch that video, sometimes we call this a power too, so it gets a little confusing, but what we're going to do today is talk about some properties. You're going to learn many of them, and those properties are just kind of shortcuts that we can do when we start doing operations with powers. And the first one we're going to talk about is multiplication and division. So we want you to try to construct a rule, come up with the rule. Now hopefully you played around with the Google Slides before you're watching this, so you've already come up with it. But we want to make sure we are on the same page with this. So let's say you're given 3 squared times 3 to the 5th, so we are multiplying. Usually you'll be asked to simplify that. Okay, well, if we expand this, sorry about the Band-Aid, guys, had a boo-boo today. If we expand this, this means I've got 2 factors, 2 factors of the base of 3 times 5 factors, 1, 2, 3, 4, 5, right? So here we get 2 factors of the base times 5 factors of the base. So all together, right, I've got 7 factors, right? Well, where does that come from without expanding? Well, 2 factors and 5 more factors of 3 would give me 7 factors of 3, right? So let's try, we'll call that our first example. How about a second example? 6 to the 10th times 6 to the 5th. Well, 1, 2, yikes, right? Dot, dot, dot. How many times? 10 factors there of 6. Times 6 times 6, right? 5 factors of 6. Well, 10 factors and 5 more factors of 6. We're going to have 10 factors and 5 factors of 6, or a total of 15 factors of 6. We're multiplying here in between, repeated multiplication here and here. So, right there. What do you think our rule is then for multiplying? If we were to state this as a shortcut. Okay. Well, x raised to, let's say, the m power. We tend to see m and n or a and b used a lot, times x raised to the n power. What's our shortcut? Well, so long as they have the same base, keep the base and add those exponents together that tell us how many factors altogether we would have, right? So in short, the rule is when you're multiplying powers or exponential expressions, I'm going to use powers just because I know the high school teachers use that word, okay? This is a key. With the same base. Has to be the same base. We just add the exponents. Okay. Let's come up with a couple different examples here. Example 3. What if we had -5 raised to the 8th power times -5 raised to an exponent of 4. Well, those parentheses are important, right? Means it's the negative that's getting multiplied over and over again. How many times? 8 times here, then another 4 times. 8 and another 4. Negative 5 to the 12. Let's try something like a fraction. 2/3 times itself 4 times, and then 2/3 times itself 5 times. 2/3 times 2/3 times 2/3 times 2/3 times 2/3 times 2/3, right? How many times are we going to be doing that? Well, we're going to do it 4 times and then another 5 times. So we add those exponents. Remember, parentheses are going to be important with fractions as well. All right, this last example, just a small little twist, a little up of the ante in terms of difficulty, all right? What if we had negative 6 raised to the 3rd power times negative 5 raised to the 3rd power times negative 6 raised to the 4th power? So now we have 3 factors in there. But these are the only ones that have the same base. And since order doesn't matter in multiplication, I'm going to show that I can move these 2 factors around. Order doesn't matter in multiplication, right? So that I can show, hey, these have the same base. Keep the base. When multiplying, the shortcut is to add the exponents. There's nothing I can do with this one, right? And so if we simplify by putting it in and keeping it in exponential form, we're just done here. If you're asked to evaluate it, we actually want to know, well, what is negative 6 times negative 6, right? 7 times. Now, for the most part, we won't ask you to evaluate those numbers unless it's one of those perfect squares that we asked you to memorize or the perfect cubes you were supposed to memorize, right? Okay, I'm going to stop there. We're going to have a different video about dividing, right?